So motion equation stuff, we're going to have several different variables. So following that four-step method of make a list, write your equation, plug in, rearrange and solve and stuff is going to be a helpful way to work through those problems, especially when you're not as familiar with them, right? So X is position, like where are you, left to right, up, down, whatever, right? That's a distance, displacement, position kind of thought process there, right? VI is initial velocity. Oftentimes we can set this up so that is zero. So if we set that up so that is zero, that whole thing drops out of the equation. So if we drop something, or when you're doing projectiles, when it gets to the top, it's zero. So if I only do part of the problem, where it's just from the top down to the bottom, it's one of the nice things in physics. You're writing the problem, or you're framing the problem however you want. So you can adjust things to make life easier for you, right? And since there's t in two places, that can be kind of helpful, especially if you're trying to solve for time, so you don't end up with a quadratic, because quadratics are awful, right? And then 1/2 at squared. The half kind of tells us at the beginning acceleration doesn't matter a whole lot. The t being squared tells us that at the beginning the acceleration doesn't matter a whole lot. But as time goes on, that acceleration is going to matter a lot because it's an exponential function kind of thing, right? So let's say let's say we drop something, right? So we drop something and it's going to drop for 10 meters, right? So X is going to be 10 meters. Let's say if we dropped it, we know something about our initial velocity. Our initial velocity is, I'm sorry, I didn't hear you there. Oh, yeah, it's a zero. Our initial velocity is zero. This is gravity stuff. So remember, gravity is 9.81 meters per second squared, but we just like to round that to 10. Now, if you don't want to, if you want to do it 9.81, you'll get a more precise answer, but that's fine, right? And then time, we want to know how long is it going to take it to fall this 10 meters, right? So, well, you go 10 meters per second squared, well, 1 second, right? It's not 1 second because it started at zero. This is the acceleration, not the speed, right? If our initial velocity was 10 and there was no acceleration, then yeah, it'd be 1 second for it to go 10 meters. So then I'm going to rewrite my equation. X equals the zero here, drops that out of the equation. 1/2 of negative 10, oh, whoops. I don't want to X there at the beginning. I want to plug numbers in here. 10, and actually since we're dropping at 10, that should be a negative 10, times negative 10 meters per second squared times our time squared, right? So multiply both sides by 2, so negative 20 equals negative 10t squared. Negative 20 divided by negative 10 equals t squared. Get rid of those. So the square root of 2 equals t. That's not an answer. That's a problem still, right? So that's like 1.41 seconds. Right? The square root of 2 is not an answer, right? We wouldn't enter that as an answer because this isn't some weird math class where people think that's an answer, right? We'll just work that one problem for this video and then work another one for the next video.